Next, we have Wes Reisz, who's going to talk to us about APIs and service meshes, a topic that I'm quite interested in. Wes is a relative recent hire to Thoughtworks, but he's been a strong contributor in the QCon, the InfoQ community for a while, and he brings a lot of expertise on cloud native technologies in particular. So please, Wes.
So let's start with a thought experiment. When you look at this page, what do you see? Now, I know you see it's Amazon, but look past that. What do you actually see as far as like the API makeup? What are the APIs that are actually on this page? If you look really close, you can first off see right off the bat my expired credit card. So there's obviously some kind of notification service or alert service that's being used to actually communicate like really important information to the user. Obviously, there's the product here. There's something behind this, like get product by ID to display the book that I'm actually showing. If you look just underneath the slash there, you can see that it's linked to my Audible account where you can actually start and listen to this book because it's in my Audible. On the side there, which is actually the bottom part of the page, you can see that the recommendation engine that's actually feeding this, that's also using this get product by ID, but maybe not displaying all of the same data. Beneath that is the more detailed stuff, and just peeking there across the bottom, you can see customer reviews. And customer reviews is, feedback from the actual folks that have read this book. So those are the APIs that you see. What about the things that you don't see on this page? In 2007, 2008, I'm dating myself, I know, but sometime around there, Amazon was famous for talking about how for every 100 milliseconds of page load time, it costs them 1% of revenue. So I can promise you there is an SLO on this page, a service level objective, that requires this page to load in a certain amount of time. I can promise you there's things about redundancy. I can promise you there's things about resiliency that if things go down, this page still loads. There's non-functional requirements that actually go to create an experience like this. Now, full disclosure, I didn't build Amazon.com. I wasn't part of building Amazon.com. But what I can tell you is the types of things that go into creating an experience like what you see on Amazon.com are traditionally built on things like API gateways and service mesh. And API gateways and service mesh are very similar. They offer very similar capabilities, but they handle traffic at a different axis of how you might think of an API. So an API gateway tends to handle things in what is called north-south, traffic that comes into some type of boundary, some type of perimeter. Where a service mesh tends to go from service to service. We call that east-west traffic. So while there's extensive overlap in these two types of technologies, there are individual cases where these things excel. And I'll also point out that these are patterns as well as products, which also causes some of the confusion. Hi, my name is Wes Reisz. I'm a technical principal for Thoughtworks. I'm also the creator and co-host of the InfoQ podcast that's out on InfoQ, and I chair a software conference called QCon that runs in the Bay Area in the fall, around October of each year. So as I mentioned today, what we're going to talk about is an API gateway. What is it? And a service mesh. What is that? What is this north-south? What is this east-west thing that you were talking about? And why do I care when I'm building experiences like I showed with that Amazon.com? Then I'm going to talk about some questions to think about when one or the other of these things, despite their overlap, might be a better way of attacking a problem that you're trying to solve with your API architecture. So we'll focus on three specific questions, specifically things like, is your API a product? There's certain cases where one may be a better solution than the other. We'll also look at your traffic. Is it internal, external, and some of your non-functional requirements on what you might need to implement. We'll look at that. And then we'll take a look at complexity and where does it make sense to handle complexity in the minds of maybe development teams or in perhaps in an infrastructure component, a platform component that a team might look at. So we'll look at those three questions. And then finally, when you've made a decision on which way you want to solve these particular problems, what are some deployment patterns that you might use to enable service mesh or API gateway? Spoiler alert, there's no silver bullet. You still have to meet your requirements to what you're actually trying to work with. So let's level set. Let's talk about this thing, API gateways. Those have been around for a while. We're probably familiar with it, but let's level set. And then we'll talk about what service meshes are. So specifically what we're focused on is north-south traffic and east-west traffic and their use cases. So we'll start with the gateway proxy pattern. So an API gateway is responsible for client to service communication. We call that north-south traffic because it guards a perimeter, it guards a boundary of something, not necessarily your network. It could be your network, it could be a server, it could be a cluster, but it guards a perimeter of something. And at that perimeter, think of it like a seam, someplace that you can inject, you can do things like security, you can do things like rate limiting, you can do things like caching. So if you're maybe in a serverless architecture and you want to prevent all that traffic from going back to actually spin up functions that cost you, you can cache it like an API gateway. So what we do is we introduce this seam where we put a reverse proxy that's called a gateway. And this is a pattern and a product that's used quite a bit to be able to solve use cases like what we saw with Amazon.com. So this API gateway pattern, it adds an additional hop, say 30 milliseconds. But at that 30 milliseconds, what we can do is insert these different pieces of technology like I talked about. And what it becomes is a centralized, just regardless of how it's actually implemented, it's a centralized deployment model where you can actually cut in to do different things into your architecture. This is if we double click just a little bit, what it might look like. You have sets of services, an API gateway, you have a control plane, and from that control plane, you can do different things at that seam that you've put at the boundary of your system, the perimeter of your system. So what are those things? I'm glad you asked. There's things like data loss prevention that you can do. What comes in must also go out. So at an API gateway, you can do things like redaction. You can prevent like SSN or credit card from leaking outside of your perimeter. You can treat your API as a product, one of the things we'll talk a bit about here, and have things to wrap around it. You can rate limit. You can do layer 7. So layer 7 is that top of the OSI model, where you have the URL, you've got request headers, you've got all this information that's there at that top level. You can do routing decisions based on that layer 7. You can return errors if it's not a correct thing. There's all kinds of things you can do at layer 7 because you have this API gateway. You can also do things like API composition. So rather than returning 5 or 6 calls from a backend network, you can call one point and compose several APIs to have it return, and then maybe cache that so you don't have to keep hitting it. You can do things like WAFs, like Web Application Firewall, which can actually protect from like bots and things that may enter your system. All these are the types of things that we have traditionally done with an API gateway. Okay, so you knew this. Now, what's that other thing, that service mesh you've been hearing so much about? So let's talk a bit about it. What a service mesh tends to do is protect east to west traffic, service to service communication. And the way that this works is we insert a little piece of technology that are reverse proxies that can actually handle some of these cross-cutting concerns. So let me back up a second. Put back on your hat of building a monolith. You're building a monolithic style application, right? When you're inside a single computer, you have access to all the processes that are actually happening there. What we've done with microservices is we've split that out and we've inserted the network into the equation to solve other problems like velocity and flow and things along those lines. But what we did is we introduced other problems because now you have a network that's in beside there. So what we've done with this reverse proxy that sits in the middle is we've created a place where we can add, again, a seam in our services to be able to extract some of these things that before we are now having to build into our apps because now we got to deal with the network. So this pattern is called a sidecar pattern. And just to be clear, the sidecar pattern is what's most commonly referred to when we're talking about service meshes, but it is not the only one. There's other service meshes out there. Cilia Mesh comes to mind, for example, that is doing things with enhanced eBPF, enhanced Berkeley packet filter, to be able to actually do things in the kernel. eBPF allows you to write code that runs into the kernel without recompiling the kernel, so you can actually do things in a service mesh that don't require a sidecar. What we're talking about today, though, is mostly going to be sidecar implementation. So things like Istio, Console, Linkerd, those are all examples of service meshes that implement a sidecar model. So in this sidecar model, with these services, we take out these things that we built these libraries into our apps and put them into reverse proxies so we can remove that from the sphere of what a developer has to do to create services. And this is called a service mesh. So a service mesh becomes this generic mechanism for intercepting microservice traffic. It lets us transparently introduce aspects such as security, routing, monitoring, testing, all kinds of great things that we can actually add, and it reduces the amount of complexity, reduces the amount of cognitive load that you actually have when you're developing these services. And because of this model, it tends to be considered a decentralized approach to building services, much more decentralized than an API gateway. So what does that look like as far as an architecture diagram? So if you think about these services and those sidecar proxies that you see here, imagine all of those together in a monolithic application. In a microservice application that leverages a service mesh, we can break those apart and remove some of those things that were maybe jars or libs that were inside of a directory and put them into a sidecar and treat them all the same across what is called a data plane. So for a second, suspend the ingress and egress. We'll talk more about that in a minute. For the purpose of this diagram, it's the point that traffic comes in, point that traffic goes out. So within this particular data plane, with these services, they talk, they're intercepted. Their traffic, when they're talking together, is intercepted by a sidecar. And that is where the network, the plumbing of how these things actually get wired together. So where does it actually get like the address, the location, the routing table? Well, there's a control plane. And in the control plane, it can do things like feed that routing table of where service A and B lives. And those are particularly important in a microservice environment where we may have services that are coming up or going down. So a sidecar handles kind of all of this plumbing and removes some of these technical things that we've had to add to deal with the network. So what types of things would you do or can you do inside of a sidecar? You can do things like rate throttling. You can do layer 7 like we talked about before, but you can also do layer 4 here within a sidecar because of where you're actually at and the access that you have to the request. There's things like auth in, auth z at the sidecar, security, resiliency, a lot of things that you're dealing with inside the app because you have the network that's there, including things like traffic routing and shaping or different deployment patterns. Those are all things that could be there. Okay, so we talked about API gateway, we talked about service mesh, and just to kind of summarize, an API gateway is responsible for the flow of requests from a client to a service. So you can do all kinds of different things there. So it's really kind of things that are often at the perimeter. A service mesh is responsible for service to service communication or the flow between service meshes. All right, so that seems pretty straightforward, right? So what's the big deal? Like, why this talk? Why are we talking about this? North-south, API gateway, east-west, service mesh, done. Thanks to the presentation, Wes. Well, the reason is because API gateways and service mesh are converging. There's overlapping capabilities that are here. Things like rate limiting, security, service discovery, tracing even, can all be done both at an API gateway or service mesh. If you go back to those two diagrams that I showed before of these capabilities, it starts to look more and more like this. These things are overlapping, which begs the question, if I can do auth in, authorization, authentication at either one, which one should I do it? So that's the first question. But then, if you're not confused yet, it gets better. Enter Kubernetes. Now, we not only have the things that we just talked about with service mesh, with sidecars and with API gateways, but in Kubernetes itself, we have an ingress, we have a service mesh ingress, and then we have API gateways, and all of them can also do north-south traffic. So which one do I do there? So what am I talking about? Let's stop for a second, back up. So Kubernetes, like when we want to run a container within Kubernetes, we'll take a container, put it into a pod, and if we want to expose that, we'll put it in something called a service. Now, if we have 5, 6, 7 services that may be operating in a cluster, we have a single IP address or different FQDNs that come in. How do we route those off that layer 7? How do we route those off to the apps that sit behind those services in those pods? We add an ingress. So an ingress does this layer 7 routing and routes things over. That's that north-south, sounds a lot like that API gateway I was talking about, right? Then when we drop a service mesh into the scenario, we also have an ingress in a service mesh. So that ingress, which is called the gateway API, not API gateway, but gateway API, which is what's being the new name of the ingress API for Kubernetes, that also comes into play with doing north-south traffic. So if you put all of these on the screen, you've got an API gateway, you've got a gateway API, you've got sidecars, and oh, by the way, if you're still not confused, all of them can use Envoy to be able to implement it as a reverse proxy. So once again, where do you put your logic, particularly if there's overlap? This is from a couple of years ago, but this is Andrew Clay Schaefer, who's one of the people who helped coin the term DevOps, talking to Christian Pasha, on Twitter, who's the CTO of Solo.io, who makes a couple products that are focused on the edge with API Gateway and Service Mesh. This is them saying, look, people are confused and overwhelmed by the different choices, and this hasn't changed in the last few years. If nothing else, it's only gotten worse. There's so many different opportunities of places where you can use an API gateway or a service mesh. So this is the problem of where we stand now. So given what we just talked about, where can we find unique places that an API gateway may be distinctive, or where can we find places that a service mesh may be distinctive? So just kind of reminding you, I'm going to bring all these back together for a second. Here's the overlap of a lot of the things, and this is representative. The initial diagram that I put together was so massive, it didn't really fit on the screen very well. So I reduced it down to some like key areas, but this is to give you like a representative of the type of things that are in that common space there. I mentioned in my intro that I do a podcast on InfoQ. A few weeks ago, I talked with Matt Klein, the creator of Envoy, and one of the things I asked him was, Matt, what's the difference between an API gateway and an ingress? To which he laughed and said, honestly, I consider myself a bit of an expert in this space, and I don't really think there is much of a difference because these things are all converging. They're converging more and more. If you're an API gateway vendor, you're probably introducing a service mesh. If you're a service mesh vendor, you're probably introducing an API gateway. These things are all merging. There's products that may target a particular space, but the underlying technology is very, very similar. So where are they not? Where can you actually see a difference for an API gateway in what you're building or with the service mesh? So I sat about that, and I really struggled on coming up with 3 questions that I thought would really represent the space. And I settled on these 3. Probably could argue that there could be 4, could argue that there could be 2. But these 3, I think, are good representation to help you think about an API gateway, think about where your actual traffic, the use case, the non-functional requirements are that you might be able to solve, and then also think about like service mesh from a complexity standpoint and how you might be trying to like solve some problems that a development team might have. So the first is, are your APIs a product? So if your APIs are a product, and I'll talk about what that means in just a second, there's some things that you might need to do around that an API gateway may be a really good solution for you. The second question is all around whether your traffic is internal or external. If you're guarding a perimeter and your traffic is external, there's things you might do at a perimeter, like I used this serverless example earlier when we were talking. Every time you spin up serverless functions, there's a cost to that. So maybe you want to protect things at a perimeter and prevent things from actually spinning up those different things. So there are reasons, non-functional requirements that may be present, like cost, that you may want to prevent traffic from coming in. Right? We'll talk about that a little bit. And then thirdly, we'll talk about complexity. A service mesh is a complex piece of software to actually operate. But I would suggest that it may be less complex than complexity you're already dealing with. So we'll talk a bit about that when you're evaluating these things. So first off, API is a product. Many times as developers, we build APIs as something that we're going to sell. Here's a few examples of them. Plaid, which does like checking, and you connect your checking account to it and they manage an API to help you deal with all that. There's Stripe that does payment processing. There's Twilio that sends messages and notifications and phone calls and things like that. These are all APIs that people build and purchase and build into their applications. These are not things that really have like a big UI. This is more about the API behind it. So let's stop for a second and think about, if you're the developer here, put your developer hat on, and you're going to build a service, something like Plaid, something like Twilio, something like what we just showed. How would you do it? What would you need? So the first thing, you have to build your services, right? So we know that. You're gonna have to go out there, you have to build your different services to do the work. That's pretty self-evident. But what else do you have to do? You're probably gonna have to have something like a self-service portal for developer registration, so your developers can go out, register, and be able to get an API token. You might have to have something for billing, for monitoring. You have to do authentication, authorization. You have to generate that API key that I mentioned and then be able to check it as it comes through. You might need dashboards, reports for your API usage. You've got to do your Swagger docs, your open API, so the documentation that's for it. And then you got to load balance, rate limit, proxy, and do things like policies. All of those things are part of creating your service. Architecturally, it might look something like this. So you have a developer consuming it, API gateway, you have services, you have API management, and you have dev portal where all these docs are. An API gateway is tailor-made to help in this particular scenario. So you can build everything at this perimeter if you want to, or you can use products that are out there in this space that actually provide some of this capability and kind of do some of the undifferentiated heavy lifting. Whether you build it or not, it's really, this is a point where APIs as a product actually excel. So this is an example of Kong, which is one of the more popular API gateways, not endorsement of Kong, but this is an example of like their plugins that are available for you to go out there. And if you don't want to build this yourself, you can enable things like this. And if you look there right underneath authentication, you can see like the portal application registration, which is something you can add and be able to kind of get that undifferentiated heavy lifting out. But this is a use case that excels for API gateways. Second question, is your traffic internal versus external? Your external traffic tends to be focused on that perimeter and has different non-functional requirements. Again, I mentioned that serverless use case. Internal calls tend to be more homogeneous, and they tend to deal with that added network between the services. So you have concerns around resiliency, reliability that you may have to actually solve. I used that example before where we were talking about monoliths. When we were all inside the same computer, we had the operating system to help us get access to things that were happening. Now we don't. So we have to build things into our applications to actually give us reliability, circuit breakers. We have to do retries when something fails so that way it doesn't go down. We have to prevent thundering herds to make sure we don't overwhelm services. All these things that we build into our apps or potentially into a service mesh to remove some of that heavy lifting. Richard Lee is the CEO of Ambassador Labs. They make an API gateway called Emissary Ingress. And he talks about the fundamental difference between routing at the edge or at that perimeter that I've been talking about, internal and east-west traffic, is that in edge, you don't control the client. So internally with the east-west, you have control of the client. When you have control of the client, you can do different things. When you don't control the client, it becomes much harder. Take TLS. Both the API gateway and the service mesh can do TLS. Both of them can do it. However, the way that they're done is slightly different, or how you might do it, the depth of what you can do it is slightly different. Take MTLS. One of the major use cases with the service mesh is you can be secure by default, so zero trust security. And what that means is basically all your services can have a certificate and they exchange. So in MTLS, a client says, hey, I need this resource. And what's going to happen is when you request that resource, the server is going to say, here's my cert. The client's going to take that and go out to a CA. When it's good, the client will get notification of it and then send it cert. The server will say, great, here's mine, send it back. And when all that's good, the server will return the protected resource. And that is MTLS in a nutshell. When you control both sides of the client, you can do things like push new certs. But when you don't control a client, which is in the case of an API gateway, then you can only protect one side consistently and reliably. If you want an example, just go out and search the web for certificates, and you'll see many of them. You'll see all kinds of them out there. This is one specifically with Spotify with a cert that wasn't updated on a public-facing cert. This is undifferentiated heavy lifting that a service mesh can help you with. So MTLS is one of the major use cases that are often used when it comes to a service mesh. So what does that look like? If we go back to this diagram with our sidecar proxies here, our control planes down there at the bottom, part of that is a CA that can actually issue certs to our sidecars. So in this scenario, each one of these sidecars can be MTLS, have certificates by default. So they trade those things and you have certificates all the way across the data plane within your architecture. In addition, so that's security. So whether you're at the boundary, you're internal or not, you can use security at different ways there. In addition, there's things like observability. At the sidecar, you have insight into the full components of the request. Again, remember back to that monolithic example where the operating system had access to all the processes for you to be able to do things. You don't necessarily have that now with the service mesh. So what you can do with sidecars is to be able to get telemetry directly off of the sidecar and be able to create a more complete view of the request that's actually coming in. So here's an example of what you might be able to get out of an API gateway. This is a product, a plugin called Mosif that's available with Amazon's API gateway. And you can plug in and you can see things like just the overall latency. So metrics, right? So request, errors, durations. You can create like the overall request for the things that are used. You can see this because it's at the entry point of where you come in. API gateways and things that you monitor at that point where APIs come in are examples of things like this that you can do. This is an example of something you can do with a service mesh. This is Tanzu Service Mesh, and what it does when you enable it, it allows to get telemetry directly off the sidecar, and this is a visualization that you can get right out of the box just by enabling something on a service mesh. So you can see like the Istio ingress here, you can see it talking to a shopping service, and then going across multiple clusters. The Tanzu Service Mesh supports multiple clusters in their architecture. But it goes across and you can see it reaching out. You can see the RPS that's going there. You can get this insight and visibility just by enabling a service mesh because at that sidecar, they've instrumented the information to get telemetry directly off it and then collect it into this visualization that you actually see. Very powerful thing when you're decomposing that monolithic application and introducing the network into the equation. Now, one warning, right? There are no silver bullets in software. So yes, it does give you a nice visual and it certainly can help you when it comes to being able to identify problems, but it's not the final answer. You still need to have developers in there, instrumenting and making sure that your app is highly observable. All right, so we talked about security, specifically around like TLS and being how MTLS in a service mesh is in particular pretty powerful. We talked about observability, how that's different. They're both implemented with an API gateway or service mesh, but they're slightly different depending on where you actually do it. But there's other things too, like deployment patterns when you're deploying like a service mesh or an API gateway. So if you think about like a canary is a piece of code that you implement, and you might have a percentage of requests that come on, and then you ramp it up, and then be able to bring it fully on. Canaries might be more powerful, or often much more powerful in that east to west traffic. Blue-green deployments might be better at an API gateway. So depending on what your non-functional requirement is on how you're deploying some of these things, you might have a better solution with an API gateway or service mesh. OpEx, CapEx. So those stand for like operating expense or capital expenditure. And so if you're using an operating expense, again, back to that serverless model where you have individual requests, you're paying for invocation, then you may want to do things at an API gateway to prevent the traffic from going there. If you've spent money on like servers, you spent money on infrastructure, you may be okay bringing them on there because you have enough capacity to be able to stop it right at the endpoint. So these are some decisions that may come in. Your caching strategies, you might want to cache at a sidecar or at a gateway. You might want to simplify and consolidate some of your architecture so that you're not maintaining multiple teams when you're actually delivering and building on this software. You also might have things like defense, like bot blocking or web application firewalls that you might want to do at a perimeter, not necessarily on the system. All of these things are very similar between an API gateway and a service mesh, but depending on where you're actually doing the work, you might have a different set of requirements and it might make sense. So this comes down to, is your traffic internal or external? Now, the third question that I want to hit on is complexity. And this is the one where I said that a service mesh is a complex piece of software, but it actually could be less complex than it is for what your developers are currently doing. So let's take an example. So let's say we're going to build an app. It has Android, iOS, it has web. We're going to build this application. Maybe it's got a mobile BFF, it's got this order detail, it talks to services, has some data behind it. Let's think about like, what do I have to do if I'm going to be putting this app together? I'm a Java developer, so I think of it in terms of Java. So my frameworks, I might be using REST template, might be using Spring MVC, I might be using Spring Boot, but I'm going to use these frameworks to actually build the things that give me this business logic that I'm going to actually put together. I have to deal with data. So I might have to decide on a relational database or whether I'm going to use NoSQL. I'm going to have to decide how I'm going to store this stuff. Is there caching? Am I going to use something like a Redis when I'm going through here? Remember the observability questions before that? They're still here. Developers need to focus on observability to make sure that MTTR doesn't get too high and you can troubleshoot an application when there's errors. Service discovery. If I'm building microservices, how am I going to find these things? Resiliency, security, deployment patterns. Again, representative here, not a complete list, but these are the types of things that you have to do when you're building an app like what I described. Let's rearrange this a bit and put it into maybe something more like a value chain. What I mean by value chain, I want to take the thing that I'm trying to do and all the things that support it and kind of arrange them into a chart. So if you look at this business logic portion here, that is the really custom, unique piece that I'm actually working. The framework, service discovery, resiliency, security, data, all those other things are supporting the work that I'm actually trying to do. And if you look at them on this from business logic on one side to service discovery on the other, they're on kind of a spectrum that goes from unique and custom all the way to commodity. So what if I can take off a large portion of this from the minds of my development team? So what if I could take all of these sections and remove it out of the concerns of the things that the individual development teams need to worry about? Well, then the scenario starts to look a little bit like this. And you can see observability there is halfway marked off because, again, you can take away some of it, but you still need to pay attention to make sure you're instrumenting your apps well. Now your developers only have to focus on this. If you're at a stage in your company's growth where you only have a handful of teams, you may not want the complexity of a service mesh. But if you have many teams and you can remove a large portion of that and place it into an underlying framework, a platform, into a separate concern, you can increase the flow, reduce the cognitive load of dozens and dozens of teams. You can deliver more software. So it may, despite having more complexity with what is in a service mesh, you actually could reduce your overall complexity in delivering software by introducing something like a service mesh. So I talked about 3 questions. So what 3 questions? Are your APIs a product? Is your traffic internal or external? And what might you do at that perimeter? And then how do you deal with complexity? Do you want the complexity in the minds of your developers, or do you want them in an infrastructure or platform component that you may be operating? These are 3 questions to help you tune on whether an API gateway might be the best solution or a service mesh might be the best solution for your use case. Now, once you've made these decisions, how do you go about implementing it? How do you go about deploying it? Well, we've talked about perhaps the most common one, right? API gateway. You saw this one before. This is really common in serverless worlds. For example, you have an API gateway. You can introduce this. This is the simplest by far. It allows you to do things like data loss prevention. You can do layer 7. You can do SSL offloading and then have things protected within a boundary. You can do caching, logging, rate limiting, WAF. API gateway, by far, kind of the simplest approach to kind of solve some of these use cases. A service mesh can be introduced and you can do some of those north-south use cases at Istio Gateway. Not quite all of the things that are an API gateway, but you can introduce some, and then you can solve some of that complexity by having this east-west communication that's available down within a service mesh. So the tracing, rate limiting, circuit breakers, all those type of things. You may have a use case where you layer an API gateway on top of a service mesh so that you could do maybe that API as a product and still do some of the routing type things at Istio Gateway. So that's there. There's even a use case where you can deploy API gateway directly into a cluster and put a sidecar. So that's one way to deploy it. And oh, by the way, just because I talk about like perimeters, I don't necessarily mean perimeters are only at your network. You could have perimeters within your company. So you may have different areas where APIs are serviced to the rest of your company. So you could have API gateways and service meshes in many different areas within your organization. All right, so today we talked about what API gateways are, what a service mesh is. We talked about some questions to think about when it comes to API gateways and service meshes. So we talked about 3 in particular of ways that you might consider this, like API as a product. We talked about complexity on where you want that in the minds of your developers. And we talked about whether the perimeter, whether it's internal or external traffic. Then we went through some different deployment options of what you can do when you've decided on how you might leverage these things. Ultimately, it comes back to where we started though. API gateway and service meshes are two patterns and technologies that have very similar capabilities that can handle traffic on different planes, north, south, east, west. Where you implement your use case depends on your requirements, your non-functional requirements, what works best for the scenarios that you need to solve for. We talked about things like security, how they may be at both places, but it has a slightly different lens depending on what you're trying to do. Same with observability. While there's extensive overlap, those three questions that we kind of highlighted kind of give you an indication of which ones might be the best for you, API gateway or service mesh. So some key takeaways, an API gateway and service mesh, they have common capabilities and these things continue to merge. Go back to that quote from Matt Klein. He said, these things look and taste a lot alike. They're very similar at this point. So focus less on the tech and more about the functionality of what you're trying to do, because both things in many cases can do what you're trying to do. With that said though, API gateways definitely excel by creating both a piece of technology or a pattern that sits at the perimeter where you can introduce a seam where you can do things in that north-south traffic. Service meshes really excel in many ways, but one of the things they really excel is in that network reliability and that giving you those things within the network, handling those network concerns that we've introduced with microservices. So service meshes tend to do a really good job in network reliability. Now, one of the questions that I've been asked on this is like, okay, I'm just starting out though. What should I do? If you're just starting out, consider an API gateway, to be perfectly honest, because an API gateway handles that north-south and it can get you quite a bit. When you start to get many teams and they all start to have these common complexity components that you need to solve for, you have security things like MTLS you need to solve for, a service mesh becomes a really good option. Regardless of your choice, you have deployment options on how you go about it. You can solve many of these use cases with just a service mesh, or you can layer on an API gateway, or you can do some things as just an API gateway. So you have choice when it comes to the different ways that you may implement these use cases. Now, as I said from the beginning, I can't tell you how Amazon.com built this specific site, but I can tell you that some combination of the patterns and technologies that we talked about, API gateways for north-south traffic, service meshes for east-west traffic, to be able to pass things before, some combination of products and tools and technologies and patterns like that is what have come together to bring the experience that you see with Amazon.com. Thank you for taking the time to listen today.